So here's a little problem. Imagine that you have an infinitely large piece of paper. It's 1/1000th of an inch thick, infinitely large. And let's say that you cut that sheet in half and put one half on top of the other half. And then let's say that you cut it again and you stack it again. And you cut that stack and stack it again. Let's say that you cut and stack a total of 50 times. Now, turn off the video for just a second and start thinking about how tall that stack of paper would be after 50 cuts. So how tall did you think it would be? Well, let's think about this. We start with one piece of paper 1/1000th of an inch thick. When we cut and stack one time, now we have 2 sheets. And cut and stack again, now we have 4. Cut and stack, 8, 16, 32, 64, 128, 256, 512, 1024. That was 10 cuts. 10 cuts got us to 1024 sheets. And since there are 1000 sheets per inch, that would be 1 inch. So after 10 cuts, we're only at 1 inch. Well, what happens when we keep cutting? Well, think about that series of numbers that we went through. 2, 4, 8, 16, 32, and so forth. What do those numbers equal? Well, they equal 2 to the 0 power is 1, 2 to the first power is 2, 2 to the second power is 4, and so forth. So 2 to the 10th power is 1024. So really what we're doing is looking at a series of numbers, 2 to the x power. And what is x? 50. So how high is the pile of paper? So let's use our calculator to figure out how tall would this stack actually be. Well, if it's 2 to the 10th power to get to 1024 sheets, how about 50 cuts? Okay, well, 2 to the 10th is 1024. We'd be looking at 2 to the 50th. So 2 y to the x 50 equals. Okay, so what happened? It looks like I lost a couple of lights on my calculator. No, that's 1.1259 times 10 to the 15th. 10 to the 15th, that's a lot of zeros. Well, that's how many sheets. Okay, well, how many inches is that? Well, there are 1,000 sheets per inch because it's 1/1000th of an inch thick. So let's divide by 1,000. Divided by 1,000 equals 1.1259 times 10 to the 12th power. Okay, that's how many inches. Now, how many inches in a foot? Well, 12, so let's divide by 12. We're still multiplying times 10 to the 10th power. Okay, that's how many. Now, how many feet in a mile? Well, it's 5,280 last I checked, so I'm going to divide by 5,280 feet per mile, and that gives me 17,769,884 miles tall. Does that make sense? Well, let's take a look. You probably don't believe that calculator thing, so let's just multiply it out, and here we are at our 10th cut. That's the 1024 we were talking about, and all we're doing is doubling, and you can see every time it just doubles and doubles and doubles, and you can imagine when you get out here, that last cut is a tough one. So we divide by 1,000 sheets, divide by 12 inches per foot, divide by 5,280, and we get our 17 million miles. Now, I thought it would be just a little bit of fun to divide by 238,857, which is the average distance from the Earth to the Moon, and we come up with 74 of those. So that is quite a tall stack. Now we could also do this with a little fun example, and that is what would happen if you had the opportunity to take a salary of, let's just say $1,000 per day for 1 month, guaranteed $1,000 a day for 1 month. At the end of the month, you would have $30,000. Now, what if instead your employer offered you 1 penny for the first day, and then every day thereafter, he would double the previous day's payment? So that would be 1 penny the first day and 2 pennies the second. That's not a whole lot of money, but let's just see how that works out. Well, you can see here that after 7 days, you're still only getting 64 cents per day. And 8 and 9 and 10. And then finally, let's see if I can't control the paper a little better. You'll notice it's getting larger. After 18 days, we finally got more than $1,000 a day. So here's our $1,000 a day option, $1,000. And it took us to the 18th day before we finally had more than the $1,000 a day guy. But it keeps going and keeps going and keeps going until at the end of the 30 days, our last day's payment is $5,368,709.12. So if we add up the entire payments, the $1,000 a day guy, and there's nothing wrong with $1,000 a day, has $30,000, and the 1 penny guy is something at $10,737,000, which I don't know about you, but that sounds better. The accumulated wages look like this, and so it took until just about the 21st day before the penny a day person finally almost caught up with the $1,000 a day person. Then, of course, thereafter, it's all about the penny. Now, why do we care about this? It's just kind of a parlor trick or something, both of these examples. But the point is time value of money. Time value of money is all about exponents. It's a bunch of 1 plus I to the x power, where x is the number of time periods. And if you think in terms of saving money, that x, that t value or n value, that exponent becomes very important. The more time periods you have to accumulate, the more you're going to have at the end. It's not just about the rate, it's about time. Start now.